class. Today we're going to be going over the basic integration methods. So some of the basic integration methods that we have is we're going to be doing the integral with respect to a constant value n and the argument dx. Now with these here, you want to make sure that we have both the upper and lower limits are in terms of x, so that when we evaluate it, that you see we get the nx evaluated from the lower limit a and then b, so we can then combine those two into here because they have this being multiplied by the same constant. We're going to go from the upper limit and then we're going to subtract it by the lower limit. This is your just basic integration method where you have any number. It could be 1, 2, 5, Hello Kitty, star, rainbow, whatever it is. Then you're going to distribute that into each term there. The next one we have, again using the same limits a to b, is instead of a constant value, we're going to have functions. So the function we're going to choose is f of x added to g of x, all multiplied by the term dx. Now when you do this, you're going to want to make sure that you distribute the dx into both terms, and then also the integral, keeping the limits the same, into both terms as well. So you then get the limits from a to b from f of x dx, and then this argument here is going to carry over into here. It could be a minus, or it could be a plus, but you have to make sure that carries over as well. And then the same limits carry over into the second function, g of x dx here. So now we have two methods that we can use, but there's still one more that's very useful, and that's the power rule. So the power rule states that you're going to make sure when you have any exponential value, constant n dx, that you're going to be adding the value of 1 to it, and then taking this exponential argument here and then putting that in the denominator and dividing by it. And because we don't have any limits here, we have to add this constant c. So let's go ahead and do an example where we show that the limit from -2 to 3 in terms of x multiplied by the function of x squared minus 3 dx. And so using the second property here that we stated before, we're going to apply that to here. So we're going to have the dx go into, and the integral go into each function. So we're going to have the integral from -2 to 3 x squared dx, and we're going to carry this negative sign over here, -2 to 3 of the constant value 3 dx. So from here we can now evaluate this definite integral using the power rule and also the basic integration method for constant value. So let's go ahead and do that here, where we have, I see that I have my x term here, so I need to, okay, my n value is 2, so I'm going to add 1 to that. So I'm going to keep, sorry, that's a mistake there, we're evaluating this, that we're going to have a 2 here, and I need to add the constant value 1, and I need to divide by that same argument here. And then using the same limits here, evaluate it for each. This negative sign is also going to carry over here. And then for this value here, or this integral here, we're going to use this same principle here. So we have the same constant 3, and that's being multiplied into both terms. So we can then combine the a and the b, with the -2 and the 3, into here, and we're always going to evaluate this particular integral from the top to the bottom here. So we're going to have a -2, just like that. So because we have here two negatives, we can cancel those out, and then eventually we're gonna visit this later. But for now, we're going to keep it as it is, but we're going to simplify it. So we have a 2 plus 1 is 3 over 3, evaluated from -2 to 3. And then here we have a 3 plus a 5 plus a 2 is 5. So we're then going to write this as a 3 times 5, which is 15. So from here, we're now going to evaluate this power rule function here, where we have the x term, which we're going to plug in as the value 3, and then we're going to evaluate that in terms of the 3 cubed over 3, and then we're going to subtract, because we're doing the upper limit minus the lower limit, the next value, which is our a, it's cubed over 3, subtracted by a 15. So we're going to evaluate this very, very, very simply, which we're going to then get a 27 when you multiply 3 times. And then we're going to have a minus, and you multiply a minus 2 3 times. You're going to get a minus 8 over 3, subtracted by a 15. From here, we see that the same thing as we did up here, that we have two minuses so that they can cancel out. And so now we're going to evaluate this over here, so that we get a 27 over 3 plus an 8 over 3 minus a 15. For this value here, we're going to show that we want all the denominators to be exactly the same. So we're going to multiply the 15 by the value of 1 for 3 over 3, so that we now have every term with a denominator of the value 3. And so we're going to get a 45 over 3. And then from here, we're going to state that we now have a 27 over 3 plus 8 thirds minus 45 thirds is going to equal a minus 10 thirds. So overall, we started with this. So we're going to state that we have this, just going to circle that, we have the definite integral from minus 2 to 3, evaluated at x squared minus 3 times the quantity of dx equals minus 10 thirds. We see here that we use we use all three of these integration methods, with the first one to do the constant value, with the power rule to do the exponential value here for the x squared, and then we use the second one to break apart the integral there. Well, thank you so much, and I'll see you in the next Learning Glass lecture.